Hi, let's discuss chapter 3. I already discussed chapter 1 and chapter 2. In chapter 1, I discussed introduction to compiler and lexical analysis. In chapter 2, I discussed parsing. In chapter 3, I will discuss syntax directed translation, runtime environment, intermediate code generation, local optimization, data flow analysis. In data flow analysis, I will discuss constant propagation, liveness analysis, common sub-expression elimination. Let's first discuss STT, syntax directed translation. In compiler, there are 7 phases. First phase is lexical analysis, second phase is syntax analysis, and third phase is syntax directed translation. Lexical analysis converts source code to set of tokens, and syntax analysis converts set of tokens to parse tree, and semantic analysis or syntax directed translation that convert parse tree into annotated parse tree. Syntax directed definition is a context-free grammar together with attributes and rule or action. What is attributes? Attributes are associated with grammar symbol where rules are associated with the production. Suppose X is a grammar symbol and A is an attribute. We can write X dot A. Here A is the attribute and X is the grammar symbol. It can be terminal or non-terminal. There can be 0 or more attribute, but there will be always a semantic action. If there is no semantic action, then it is normal context-free grammar. If you are adding some semantic action, then it will be STT. Let's see one example. S derive AB print TOC. So this is a semantic action for this production. This semantic rule is associated with the whole production. Then A derive A print CD. This is a semantic rule for this production. Then B derive B print algorithm. This is a semantic rule for this production. In this STT there is no attribute. We just added semantic rules. There can be 0 or more attributes. Attribute is not compulsory, but there should be some semantic action. STT have lots of application. First application, it can construct annotated parse tree or called as decorated parse tree. Then store type information into symbol table. Then to evaluate algebraic expression, we can evaluate algebraic expression with the help of STT. Then to verify variable declaration, type checking, type conversion, type equivalence, etc. To convert postfix or prefix notation, to generate intermediate code and target code, to verify proper use of operator, and to construct DAG. So these are some of application of STT. We'll check it later. For STT, input is a parse tree from syntax analysis, whereas output is a annotated or decorated parse tree. So what is meaning of annotation? Annotation means if you are adding some extra note or extra comment or information, that is called as a annotation. That is in normal way. In compiler, what is annotation? If we are adding some attributes to a identifier, that is called as a annotation. What is annotated or decorated parse tree? A parse tree showing the values of its attributes is called as annotated parse tree. If we are showing values of its attributes at every node, then that is called as an annotated or decorated parse tree. This sentence is important. Understand carefully. Before we can evaluate an attribute at a node of a parse tree, we must evaluate all the attribute upon which its value depend. It may depends on its child or its parent or sibling. So before evaluating a node, we must evaluate on which it is depend. Let's see one example. There are some production with semantic rule. Some production plus semantic rule, that will be STT. E derive E plus E. Here BAL, that is a attribute for E. E value equal to E1 value plus E2 value, 1 and 2, just to identify that these are child, these are different from this E. Then E derive E multiplication E. Semantic rule is E dot value equal to E1 value multiplication E2 value. E derive ID, E value equal to ID dot value. So this E, E1, E2, these are the grammar symbol, whereas this value is a attribute. Then you are taking one input 2 plus 3 multiplication 5. So what should be output? 3 multiplied 5, it will be 15. 15 plus 2, it should be 17. How will construct the annotated or decorated parse tree? First we will construct abstract parse tree, then we will add the annotation. So E derive E plus E. Then from E we will derive ID. From this E we will derive E multiplication E. Then from both E we will derive ID. This is a normal parse tree for this grammar without using any semantic rule. Now we'll add the annotation. For solving this E, we should know this E value and this E value. Then only we can solve this. So the parent is dependent on its child. Even for this E, we should have value for this E and this E. So before parent, we should evaluate the child. And this E value will assign from this ID. This E value will assign from its child ID. Here also this E value will assign from child ID. So according to this sentence, we must evaluate all the attributes upon which it depends. So before evaluating the parent, we should evaluate the child. Means we will evaluate in bottom of order. What input is given? Input given is 2 plus 3 multiplication 5. So this ID should be 2, this ID should be 3, this ID should be 5. So ID dot value will be assigned as 2 and this value will move to E value. As here it is written E value equal to ID value, and whenever you are doing the reduction at that time you can pass the value. So here from ID we are reducing to E. So E value will be 2. This red arrow mark, that is for dependency graph. E value dependent on ID value, that shows by this arrow mark. Next, this ID value will be assigned as 3. ID dot value will be 3. Next, we will evaluate E. So ID value will be assigned to E. E dot value will be 3. Next, we will assign 5 for this ID. So ID dot value equal to 5. Next, we will evaluate this E. E dot value equal to 5. From the red color arrow mark, you can identify the dependency graph, how data flow in this parse tree. Next, for evaluating this E, we should have value of its child. Yes, we already have value of its child. Now, E value will be 3 multiplication 5, it will be 15. Now, before evaluating this E, both child should be evaluated. So, this E value will be 2 plus 15, 17. In next lecture, I will explain about attributes. There are two types of attribute. One is synthesized and another is inherited. Here, this example is a synthesized attribute. If parent is dependent on its child, that is synthesized attribute. If child is dependent on its parent or on its sibling, that is inherited attribute. For synthesized attribute, we always evaluate bottom of order. If this lecture is helpful for you, please like and subscribe. Thank you.